Welcome. Today we are ringside for what might just be the digital showdown of the century. In one corner, you've got the reigning, undefeated champion of the world, classical computing. And in the other corner, the mysterious, mind-bending challenger, quantum computing. But trust me, this is no ordinary fight.
See, here's the twist. This isn't really about one machine being faster than the other. No. We're talking about a fundamental, deep-down shift in how a machine actually thinks. It's a completely new species of computation, one born from the totally bizarre, almost magical rules of quantum physics.
So, let's get to the tail of the tape, shall we? Our champion, classical computing, this is the bedrock of our entire digital lives. It's all built on absolute certainty, ones and zeros, yes or no. But the challenger, quantum computing, it plays by a completely different set of rules, straight out of the quantum realm. Okay, to really get what's going on in this fight, we've got to start with round one, the logic. It all comes down to the fundamental building blocks of information, the good old bit and its kind of wild cousin, the qubit. So the classical bit, it's simple, it's reliable, and it is incredibly powerful. Just think of it as a light switch. It's either off, which is a 0, or it's on, which is a 1. There is absolutely no in-between. And this binary black and white certainty, well, that's what has powered every single digital innovation for the last half-century.
And now, let's talk about the qubit. Instead of a light switch, I want you to imagine a spinning coin. Now, while that coin is spinning in the air, is it heads or tails? The answer is, well, it's kind of both, right? A qubit can be a 0, it can be a 1, or it can be a weird mix of both at the exact same time. This wild property is called superposition. And that, my friends, is the secret sauce behind quantum's incredible power.
And that superpower brings us right to round 2, power. This is where we get into the stuff you've probably heard about, the most hyped-up part of quantum computing. It's unbelievable, almost ridiculous speed.
But hold on, we need the right way to think about this. A classical computer, the one you're using right now, it's like a Honda Civic. It's amazing, it's reliable, it's perfect for 99% of what you need to do every day. A quantum computer, though, that's a SpaceX rocket. You would never use it to go to the grocery store, it's just terrible for that. But if you want to go to Mars, well, it's the only tool for the job.
So, the real question is, what's the scale of this impossible mission speed we're talking about? How much faster is it, really? You might want to brace yourselves. Okay, just look at these numbers. A physics simulation on a Google quantum processor took just over 2 hours. The world's fastest supercomputer would have needed 3.2 years to do the same thing. In another test, a simulation that took a quantum computer just a few minutes, well, that would take that same supercomputer about 1 million years. This isn't just faster. This is a different reality altogether.
And what are these impossible missions exactly? We're talking about things like simulating new molecules to create life-saving drugs, designing incredible new materials for hyper-efficient batteries, optimizing massive global logistics networks in real time, and yeah, on the darker side, potentially breaking the very encryption that protects all of our data today.
Now, this usually leads to a huge myth, that these quantum rockets are going to replace our everyday computer civics. But that's just not the future. The reality is going to be more like a tag team, a super powerful partnership. So don't worry, your laptop is safe.
And hey, don't just take my word for it. The experts all agree. The consensus is crystal clear. Quantum isn't a replacement. Think of it as a powerful coprocessor that's going to work side by side with our classical machines.
So here's how that partnership's going to work. Think of your classical computer as the reliable manager. It runs the show, handles all the normal day-to-day tasks. But when it hits one of those impossible problems, it doesn't just give up. Nope. It calls in the specialist, the miracle worker, and that's the quantum processor. The quantum chip crunches that impossible calculation and then just hands the beautiful, elegant solution right back to the manager to use.
And this isn't just some science fiction dream. The industry actually expects this hybrid manager and miracle worker team to be the new standard for high-performance computing as early as 2035. So, with this unbelievable power right on the horizon, we finally arrive at the final round. And this one isn't just about the technology anymore. Oh no, this is a global race for quantum supremacy, which basically means being the first to solve a problem a classical computer literally can't, and there are trillions of dollars on the line.
The scale of this whole thing is just staggering.
The quantum computing market isn't some tiny niche. It's projected to be a $125 billion industry by 2030. That is a massive economic shift, and it's happening right now.
And you better believe governments all over the world are taking notice. National strategies are being rolled out, and public investment money is just flooding in. This chart shows a really fascinating breakdown. You can see Asia is leading the public investment charge with over half the global total. Then comes Europe, and then America. A true global competition is definitely underway.
And you know what? Private money is moving even faster. Venture capital investment in quantum startups didn't just grow, it exploded. From $789 million in 2023 to nearly $2 billion in 2024. That's a 138% jump in a single year. That tells you investors really believe the miracle worker is ready for prime time.
So where's all that cash going? Well, it's mostly flowing into three main bets. First up, hardware. That's all about building more powerful and stable quantum chips. Second, software, designing the killer apps to actually run on these things. And third, security. That's the huge race to build encryption that can actually withstand a quantum attack.
And that all brings us to our final question. With billions of dollars on the line, it's really no longer a question of if quantum will change the world. It's a question of how. So looking at the board, I have to ask you, where would you place your bet? On the foundational hardware, the game-changing software, or the absolutely essential security? The race is on, and the bell has officially rung.